Hello guys, welcome to my C++ programming class. Throughout this course, we will be learning the theory, principles, techniques, some basic elements, syntax, and everything you need to know about C++ programming. Also, I will show you the code samples for certain cases in every chapter, okay, so that you can understand more easily. But before we go further into all these elements that I mentioned just now, so it is good to explore yourself first about this history, some of the background of this programming, and some components related to it. Just like before you start learn how to cook, you must understand first what are the ingredients that you need to prepare, and also to know how to operate a cooking appliance such as the microwave, gas stove, and so on. Okay, so before we start, here we have three windows on the screen. So on the right hand side we have a presentation slide, and the top right corner we have an online compiler. So to compile the code sample that I'm going to show you later in every chapter. Okay, and the last screen is me. Okay, hello. So without further delays, let's begin with our first subtopic, which is what is a computer system. Okay, computer system is basically a combination of a software and a hardware to form a functional computer for the user to operate. This computer system is able to receive the input from the user and then process the data or this input given by the user, manage the data, and finally present all this useful information in a meaningful format. So now let's talk about hardware first. So what is the hardware? Hardware is a physical part of a computer. It's the part that you can touch it, or you can sense it, or you can hold it with your hand. For instance, computer monitor, mouse, headphone, keyboard, CPU, and etc. And this hardware is constituted by three components, which are the input, process, and output. So the input here refers to the items that is able to generate the input and, and fit into the computer system. Okay, for instance, we have the keyboard that allow the user to key in the word into the text file, mouse to navigate the cursor, we have a touch screen, and so on that you probably give something into the computer system to process. So now we have this process components. Process is a series of instructions that control how and when the data item is input, and how the input are being processed into useful information, and what form the information are output or stored. And this is the place where all the calculations, validations, storing come in. Okay, the example of the process here is the CPU. Okay, central processing unit. And the last component here is the output. Okay, so output is a useful information that produced by the computer system, such as a monitor screen to display the information, a speaker to produce the sound to the user, and printer to print out the information, the data. Okay, so however, the hardware that I mentioned just now is just a physical part, or by definition is a programmable machine designed to follow the instruction. So without instruction, a computer or hardware is nothing. It is just for a display purpose. Okay, so in order to instruct the computer to do work, to perform some task, a series of instructions is needed in the computer memory to instruct the computer to perform the task. So my question now is, who is going to give this instruction to the computer? Okay, the answer is you. You are the future programmer. Programmer is the person who writes the instructions to make the computer to perform a task. So bear in mind, without programmers, there is no program, and no program, a computer cannot do anything. So you, as a future programmer, you are quite important in this role. And throughout this course, I will teach you how to construct a proper program, and also how to to learn some useful principles, some rules, some syntax that you must follow to generate a good program, and so on. So guys, please do not skip any of my lessons. Okay, so let's move on. As I mentioned earlier, you as a programmer, okay, you need to write a program or the instructions to instruct the computer to do work. So in this case, you need a platform that allows you to write the program. So this is where the software comes in. So by definition, software is a collection of the programs and the data that instruct the computer what to do. Okay, so we have two software here, two types of software. The first one is system software, also known as operating system. Operating system manages the computer hardware and the other software applications. So this operation system will act as a middleman or the intermediate between the computer hardware and also the computer user, which is you, which is us. Okay, so bear in mind the user cannot directly connect or give command to the CPU in the machine language. Okay, also CPU cannot interact with the user directly. Okay, in this case we need a middleman, which was so-called OS, operating system, to communicate and translate all these interactions between the user and the CPU. Okay, and the most common operating system are such as the Windows, Unix, Linux, Apple iOS, Google Android OS, and so on. So beside this system software, we have another type of software known as application software. Okay, it is a software tools or utilities which the user run to carry out their tasks. For instance, word processor, games that you play every day, and browser that you are opening right now to watch this video. Okay, so by combining the software, which is the application software and the system software, and this hardware that I mentioned just now, it forms a complete computer system. As I mentioned earlier, hardware in a computer system is just a physical part. So as a programmer, we need to write a program to instruct a computer to perform some tasks. Okay, and the program is a series of instructions to order this computer what to do. Okay, and there are two very important criteria or the components that you have to take note in writing a program. And these two components are very essential and pretty crucial, and in no matter what programming languages that you are dealing with. Okay, the first one is syntax. It refers to the spelling and grammars of a programming language. Different programming language will need different syntax to write a program, just like a Chinese essay, English essay, or any other languages that you need to follow their grammar rules in order to form a complete and valid sentence. Okay, and the second component here is referred to algorithm. Algorithm is a sequence of instructions written for computer to solve a problem. And later on, I will show you some techniques on how to plan your work, how to plan your step, how to write algorithm before going to writing a good program. Okay. So before we explore in more detail what is the syntax for C++, so it is quite important that as a good programming practice, you have to plan your work first before start writing any code. And this planning or the step here will refer to algorithm. Okay, let's take a look for these real life situations of what is the algorithms. Okay, for instance, tonight you would like to go for to a cinema to watch a show after such a stressful day. Okay, before you can enjoy the movie in the cinema, you have to queue up first to wait for your turn before buying a ticket, right? So next you have to go to the designated counter and order your ticket. State what is the movie name, time, and seat number. And finally, you have to make payment. And next, to get the ticket, and finally, you leave the counter and enjoy the show. Can you get a ticket without making a payment? My questions. Can you get a ticket without making a payment? No. You have to follow the sequence or the order rights. It's so same as the programming. To write a good program or to produce a good system, you have to plan your step. Think about the necessary requirements first. Okay, and this series of steps will definitely help you in developing a good programs in more organized way. So this is normally what I will do before I start to write a good program. I will plan my work first, work out this algorithm using the technique that I'm going to show you later. Okay, so before I show you all this technique on how to write a good program, let's move on to some history and the backgrounds of these computer languages. And there are three different categories of the computer languages to write a program. The first one is the machine language. The second one is the symbolic, or we call it as an assembly language. The third one is the higher level language. So the language that you are going to learn in this course fall into this category 3, higher level language. So in 1940, this machine language was developed and being used. And technically speaking, at that moment, this is the only language that a computer can understand. Okay, machine language is instruction that consists of a binary number such as 011001. Okay, bear in mind, computer can understand only machine language, which is 0 and 1. Okay, however, these binary notations is quite difficult for human to understand and to learn. So this is where the assembly language comes in 1950. Okay, this assembly language is the first step to improve the programming structure and to make the machine language more readable by the human. So as you can see here, the abbreviations here used by this assembly language, like additions, it becomes a short form ADD, subtractions SUB. Okay, it is more easy to program and it is more understandable compared to the machine language. Okay, and since again the computer systems recognize only machine language. Okay, computer recognize only machine language. Therefore, we need a translator to help us to translate this program written in this assembly language into the machine language for the execution by the computer later. So this translator, we call it as an assembler. Okay, this assembler will help us to translate all this assembly language into the machine language and then understand by this computer and to perform some tasks. Okay, but however, this assembly language is still quite difficult to learn by humans. Okay, so in the years 1960, the higher level language has been developed. So this higher level language uses the English like code and mathematical operators like plus, minus, star as a multiplications, and then divisions, and so on. Okay, so it is more easy to understand compared to the machine language and also the assembly language. So some of the example for those higher level language is like Python, C++, C, C#, Java, and so on. Okay, and again, this higher level language cannot be understood directly by the computer system. It needs a translator to translate all this higher level language into the machine language. So this translator, again, we call it as a compiler. Okay, this compiler will be used to translate a program written in the higher level language to the machine language. So one of the main advantages to this higher level language is it is much closer to the logic of a human language. Therefore, it is easy to learn. Okay, it's not difficult, it's quite easy to learn as long as you know the logic behind, you know the syntax, then definitely you can write a good program and follow the technique that I'm going to show you later. Okay, so there are two ways to write a program. The first one is through the text editor, such as a notepad. The second one is the IDE. So IDE stands for Integrated Development Environment. It is a software package that provides an editor, compiler, and other programming tools such as the VS, Android Studio, Spider, and a lot. Okay, so in this course, we are going to use this Microsoft VS with this C++ environment. So I have prepared a short video on how to install this software properly. So I will provide the link later, the top right corner, and also in the description box. So you can just click the link below to get more info Okay, so this is the actual layout for this IDE in the Visual Studio. We have this we so called as a text editor. Okay, allow the user to write their coding. So all this coding is will known as a source code. Okay, all this coding will be stored inside this CPP file. Okay, will be stored inside this CPP file, and we have output to check the status, and then we have a solution explorer. Here is a special window that enables the user to manage the solutions, project and files. So it also provides a complete view of this file in the projects. So it enables you to add and to remove some files, to organize files into the subfiles. Okay, so I will show you in more detail later in the lesson letter. But this is the overall, or this is the overview for this Visual Studio. So how a higher level language actually works. Okay, basically there are 5 main steps involved in a higher level language, which are editor, compiler, linker, loader, and execution. Okay, firstly, the programmer needs to write the program into the text editor, and the code here we differ as a source code as I showed you just now, .cpp file. So when you have done writing your code, so you need to build and run the program. Okay, if you go through this compiler process to check whether the written program is obey the rules or not, such as the syntax rule. Okay, if everything is okay, no syntax error, then it will translate all this source code into the machine language, or we call it as an object program. Okay, and since your object program may include some SDK. Okay, so before we go further, what is SDK first? SDK stands for Software Development Kit. Okay, it is a set of software tools and the program used by developers to create the application for specific platforms. And this SDK tool will include quite many things, such as the libraries, documentations, code samples, processes, and guides that developers can use and integrate into their own apps. For instance, you are developing a new gaming apps here. Okay, and you want the user to log in the apps using the Facebook account, and it is unlikely that you need to write the program for the Facebook part. Okay, so what you can do is you just import this Facebook SDK into your apps instead of building it from the ground up. So it saves time and is more efficient. Okay, and since your codings include some SDK, which is from the different libraries and from your own writing code, okay, your code that you write just now, so we need this linker. Okay, we need another process which is linker to combine all these object programs to an executable code. Okay, and then loader, another process, will load this executable code into the main memory, and finally execute the program. Now I will show you some tips on how to be a good programmer. You just need to follow these 4 steps. Just 4 steps. Firstly, fully understand the problem of your system first. Know what are the requirements needed and the output of your system. Do not rush to write your program. A lot of students, they are making the same mistake. Once they understand the problems, they skip this step 2, straight away go to writing a program. And finally, they found out their program consists of a lot of logic errors. Okay, so please do not skip this step 2. If you really fully understand these problems, requirements, follow the step. What is the step 2? Develop a solution or plan your work. Develop your algorithm using the technique shown on the screen: structure chart, pseudocode, and a flowchart, which I'm going to show you in more detail later. Okay, once you have this proper planning of your system, then only you move to the next step 3, which is writing a program using the technique that I mentioned just now, together with the C++ programming syntax. Okay, once you have done this program, you have write this program out, you have to test your program. Test and rerun again, run and test. Make sure it is free of logical error. And it is necessary for you to go backwards or go to the previous step if you found any errors. Okay, maybe you have a wrong interpretations of this problem in the beginning, or maybe in some program, during the writing program, there are some logic errors. Okay, so here I'm going to give you some very simple questions here. Okay, you are given a task to calculate the area and the perimeter of a rectangle and write the program to solve this out. Okay, write a C++ program to calculate the area and perimeter. So remember the tips that I shared to you just now. What are the 4 steps? Understand the problem first. Okay, what are the requirements? What are the outputs? Also in these questions, the problem is to calculate the area and the perimeter. And the requirement is you need to display this result on the console. Okay, so in order to get the solution, in order to solve these problems, so what are the requirements that you need? What are the parameters or what are the formula that you need to solve this problem? Okay, so identify first the length. You need the length and the width to give you the result of this perimeter and also the area. After that, you need to identify what are the suitable formula to get this perimeter and area. Okay, so once you have identified the problem and come out with these parameters and equations, then only you go to the next step, step 2. What is the step 2? Develop a solution, plan your work, plan your algorithm. Okay, so there are 3 techniques: structure chart, pseudocode, and flowchart. You can use either one of the tools here to assist you. So as a good practice, please do not skip this step. This step is going to help you to write a good programs easily. Okay, so let's at the first technique first, structure chart. Okay, so this structure chart is basically a hierarchical chart that shows the functional flow through the program. It shows how the program is broken into the logical step, and each step will be separate modules. For instance, we have this area and perimeter. The first level is always be your problem statement or the objective that you are going to achieve. In this case, you are going to find out this area and the perimeter of a rectangle, right? So this is your objective. And now you break down into another 3 modules. These 3 modules basically are the tasks, individual tasks that you are going to achieve later. You have to get the length and the width from the user first task. Next, you have to calculate the area and the perimeter given this length and the width. And this task is to display the result, to display the output, which are the area and the perimeter. So I don't really encourage students to use this structure chart if you have a very simple and straightforward questions. This technique is commonly used when we have a solution that involves a lot of functions. Okay, so I will show you how to use this structure chart properly in lessons functions. Okay, stay tuned. So let's move on to this another techniques, pseudocode. So this pseudocode is a mixture of the C++ programming and this ordinary English. It contains the logical step to accomplish the task. And here are some guidelines to write a good pseudocode. Okay, the first one, you have the start and the end point. Okay, always start with this start entry point, and you must have this end as an exit point. Okay, and second one, use the numbering system for each of the instructions, but this is optional, it's up to the student. Okay, and the third one, only one instruction per line. Okay, there's only one instruction per line. Okay, you cannot have 2 instructions in one line. No? And the last tip here is the instructions is follow the sequence. Okay, you get the length and the width from the user, then you process your parameters, and you get the result, you display the result. Okay, so now let's move on to the last technique, which is the flowchart, which I think the best tool, this flowchart is the best tool for me. Okay, I would always recommend my students to use the flowchart to plan their work, to plan their step before writing a good program. Okay, so what is flowchart? Flowchart is a type of a diagram that represents the algorithm, workflow, and the process. Okay, and there are 8 standard flowchart geometry symbols. Okay, input, processing, modules, terminal, decision, flow lines, and so on. So you don't really need to memorize all this diagram, as you are a future programmer and there will be a lot of chances for you to write a program and plan your work first using this flowchart. So automatically all this flowchart diagram you just somehow install inside your brain. Okay, so come back to the question just now. Okay, we have the questions to find out this perimeter and the area of a rectangle, and you have identified the parameters, length and the width, and also the formula to get the result, right? Okay, so to start planning your work in using this flowchart for these questions, first thing first, you have to start with this terminal. Okay, start with this terminal using this symbol, terminal symbol. Okay, so what is the next step? Next step is you have to get the user input for the length and the width. Okay, you have to get the input for the length and the width. So since you are getting the input, so you have to use this input geometry, this symbol. Okay, once you have this input length and the width, you have to calculate, process what is the area. Area equal to length times width, and what is the perimeter. So this is the processing. Okay, computing. So you have to use this processing symbol to calculate the area and the perimeter. Finally, to display your result. Okay, using this tilted rectangle. Finally, end your flowchart with another terminal and. Okay, it's pretty simple, right? So once you have planned your work using this either flowchart, pseudocode or structure chart, move to the next step. Write a program. Okay, with the help of this flowchart and some knowledge of the C++ syntax. So this is the step 3. So this is the framework of the C++ program, and we have 2 parts here. First part is the directive, and the second part is the body. Okay, don't worry about this line 1, 2, 3, 4, 5, 12, which I will cover later. Okay, now we just focus on how to solve the question just now, how to get the perimeter and the area of a rectangle. Okay, so now you refer back to the flowchart, width, length and the width, right? So in the C++, the syntax to get the user input is cin and this operator. The arrow go to the right hand side, double operator here. Okay, and then you would like to get the length input and the width input. So what is the next step? You have the input, then you have to process, calculate the area, and calculate the perimeter. So the arithmetic operator in the C++ is just like the mathematical operators that you have been used since the kindergarten. So I will cover more about these operators in the lesson later. Okay, so and finally we have to display the output, display the area and the perimeter. So in C++, the syntax to display something on the console by using cout and this left hand side operator. Okay, so now next step. What is the next step? Last step, test your program, right? Okay, so now let's try the program. Okay, now we have done our step 1, step 2 and step 3. So what is the last step? Test the program. Okay, so now let's move on to testing the program. Look at this top right corner for the online compiler. We have a directive. Then we are asking the user to key in the length and the width of the rectangle. And then the user will key in the values, process, and then finally display. So let's run the program. So can you see the sentence? Enter the length and the width of the rectangle. Okay, so I key in 10 and 20. Okay, so I press enter. then it will process. Finally, it will display the result. Area equal to your answer 200 and parameter equal to parameter. Okay. So remember, always follow this 4 steps if you want to be a good programmer. Identify the requirements, problems, what are the output. And next, plan your work first using pseudocode, flowchart, structure chart. Third one, start to write your program based on the flowchart and with some C++ syntax. And finally, test your program. Make sure it is free from error. Okay. So here is the exercise. So by using a structure chart, a pseudocode and a flowchart, find out the total and the product of two numbers. Display the result. So in this exercise, I'm not going to ask you to write a program, but just to plan your work using a structure chart, pseudocode and flowchart. Okay, so I'm not going to give you the answer for this exercise. So take out a piece of paper and a pen and work it out by yourself and comment your answer at the below. Okay. So one of the criteria that a programmer needs is debugging. So debugging is a process to eliminate the error in the program. So in programming world, we always refer the error or the mistake as a bug. Okay, as bug. So by definition, a bug is an error, also known as an exception, occurs during compilation or execution. So you as a programmer, your role is not only write a program, but you need to find out the bug and catch the bug to solve the errors. Okay, so there are 3 common errors in the programming: syntax errors, also known as a compilation errors, runtime error, and logic errors. Syntax error is the code violation during the compilation process. So means that you didn't follow the grammar rules set by the particular programming language. For instance, missing semicolon. Okay, missing semicolon. So what happens is I missed out the semicolon and I run the program. It will show me the errors. Where is the semicolon? Okay, so it will tell you should include the semicolon. So this is syntax error, one of the example of the syntax error. Okay, now I solve the bug. I know that there's a syntax error in my program. You undefined variables and you didn't use the symbol when you're using these commands. And we have this runtime error. It's an illegal operation occurs during the executions. For instance, divide a number by 0, which is impossible, right? You cannot divide a number by 0. Okay, you can take out a calculator, try to divide a number using try to divide a number with 0 by 0. Let's see what happens. Okay, so I can try here. So I use links. Okay, parameters. For instance, with divide by 0. So 1. It will give me a warning, division by 0. This is runtime error, something wrong with your program. Okay, so another example, open a non-existing file, write to a non-existing printer. All this belong to runtime error. So we have a last error known as a logic error. So this logic error specifically paths the syntax and the runtime error, but produce the false result. It's commonly due to the human mistake. Okay, for example, we have this coding. We have a equal to 20, b and other variables equal to 34. So what is the average for these two values? So what is the formula for the average? It's a plus b divided by 2, right? But in this case, somehow I did some mistake. Okay, I just put a plus b. So it will give me the output a plus b equal to 54, right? So it still produced me the result, but however the result is wrong, it's false, because I used the wrong formula. This is logic error. In logic error, it will still produce the result, but it's wrong. In the previous case, syntax and runtime error will not produce any result for you. It just throw you the errors. Okay, it will just throw you the error without providing any result to you. So before we end this lesson, let's go through briefly about this basic syntax. So I'm not going into detail about the C++ syntax, because as we go through a chapter by chapter, you will experience more and explore more about all this syntax. Okay, so what I'm going to show you now here is the basic structure of the C++ coding. We have a two part here. The first one is the directive. The second one is the body, function body. So now let's look at the first line. This is the hash sign include. It is a processor directive. It is a command preceded by the hash sign. Okay, this is a directive preceded with this hash sign, and this line are not program statement. This is not program statement, but the directive for the preprocessor. Remember that there are 5 main steps in the higher level language that I mentioned earlier. Okay, so actually before this compilation process, there's another quite important process here, known as a preprocessor. So this preprocessor will examine and resolve all these directives first before the actual compilation take place. Okay, we have a very simple C++ program. Okay, we have a few directives here: include, defines. So everything that preceded with this hash sign, we call it as a directive. Okay, so this IOStream directive I will explain in more detail in the next lessons. So let's take this hash sign define as our example here. Okay, so this define is basically to define a constant in our program, where we have a length storing a value of 10, we have a width storing a number of 5. So before the actual compilation process takes place, the preprocessor will come in first. This processor will assign the value into the variables length and the width. Okay, whenever there is a length and the width in the program, it will assign the value first, assign 10 and 5 into these variables, and then only go to the compilation process. Okay, so we have header file IOStream, where I will explain in more detail in the chapter 2. And line 3 we have an integer main. It's a command that indicating the program execution begins after this line. And we have a line 4 and line 10. Here is the braces to include a set of the instructions within this code, okay, or within these functions. And line 5 we have a variable declarations involving this data type and the variables. Also I will include in the next lessons. And we have a command here. Command is just a note for the user to write down what is the purpose for a particular statement, and this command will not be executed during the runtime. Okay. And line 6 here, cout and cin, as I showed you just now, cout is to display something on the console, and cin to ask the user to give some input to the computer. Okay. Okay, and you can see here we have one backslash n. So what is this symbol? So this is the escape sequence. So what is the purpose for this escape sequence? So look, take at this example. You look at this online compiler. So okay, for instance, enter length and width of a rectangle. So if let's say I would like to add a new line, I don't want to display this in the one line, I want to display this enter length and the width of the rectangle in 2 lines. So I just need to add this symbol backslash n, and I run the program. Okay. you break this one center into two and make a new line for me using this symbol. We call it as escape sequence. Okay, we have a line 9, return 0. It shows to exit a function, and the value 0 indicates that the program has terminated successfully. Okay, so the remarks here, use the statement, use the semicolon to end of the statement. So a statement without this semicolon will treat as a syntax error, but however not all the statements need to be terminated using a semicolon. Last but not least, as a good programmer, you must always practice these 5 good programming habits. First one, use the program comments. Always use the comments in your coding. Okay, for instance, okay, here I should put a variable declaration. Okay, for instance, variable declaration. Okay, so maybe this one to calculate the area and so on. Okay, always put the comments. Okay, remember, always put the comments. Why? Because we are human, we cannot remember everything in our brains. Okay, so just put a comment right after some important statement, so that in future if you want to read back, it will trigger your memory. Okay, so second one, use a meaningful identifiers. So identifiers is a name that assigned by the user for a program element, such as the variable, type, class, functions, namespace, and so on. So I will cover more about this identifier in the next chapter. Okay, and the third and the fourth habits are design a clear statement and clear instructions. Okay, using the tools that I highlighted just now, flowchart, structure chart, and pseudocode to help you to design your works, to plan, to come up with a clear statement. And last but not least, always back up your code using different file name. So that's all for our first lesson. So I hope you are enjoying watching this video. And remember, if you want to download the Visual Studio, I have provided the link in the description box. And I will see you in the next lesson. Bye.